Good afternoon and welcome to a webinar on employee safety measures, including Lockout-Tagout, hosted by EAS Consulting Group and presented by EAS independent consultant John Anderson. EAS, a member of the Certified Family of Companies, is a leader in regulatory solutions for industries regulated by FDA. Our global network of over 150 independent advisors and consultants enables EAS services, providing proactive regulatory compliance. From regulatory strategy development, compliance assistance, and assurance of safety programs through the planning, auditing, and training, EAS offers the detailed knowledge and experience your company requires to ensure accurate and timely assistance. Today's presenter is EAS independent consultant John Anderson. John assists EAS clients with occupational safety standards and compliance, including conducting audits, customized trainings for plants, distribution centers, and warehouses to ensure a culture of safety specific to each work environment. As a reminder, during the webinar, you may ask any questions by typing them into the questions box. And with that, I'll say thank you again for joining EAS, and I'll turn the presentation over to John.
Okay. Thank you, Amy. I appreciate that. I appreciate the introduction, and thanks to the EAS Consulting Group for sponsoring this webinar. I appreciate the time our listeners are taking too to listen in on this webinar. We've got a lot of information to cover, and I just wanted to start by saying that obviously we are all going through some very strange times right now, and I want to express my gratitude for our employees in the food industry, in manufacturing facilities, and our employees of distribution centers, delivery drivers, truck drivers, and all of us, all of you who are working to ensure our food supply is safe and plentiful. My hope, my family and I hope and pray that you and your families are safe, and that your employees and their families are safe and healthy also. Our hearts go out to the families who have lost loved ones because of this pandemic. But keeping our employees safe and healthy is why we are here. It is the sole function and goal of our safety profession. Keeping our employees safe is the purpose of this webinar. And to me, honestly, this program, the control of hazardous energy, or Lockout-Tagout as we often refer to it, is, in my opinion, one of the most important, if not the most important, required safety program that we will implement and manage. So today the goal is to explain the standard and explain how to develop equipment-specific lockout procedures, discuss the required inspections and training, and some of the exceptions and alternatives to lockout. But first, let's talk about some of the basic elements in the standard and some definitions and terms. Our employees who service or maintain our machines may be exposed to serious physical harm or death if the energy that drives these machines is not properly isolated and controlled. OSHA will estimate that the Lockout-Tagout standard prevents around 120 fatalities and maybe about 50,000 injuries each year. Workers injured on the job from exposure to hazardous energy lose on average about 24 work days to recover. Injuries that happen because equipment was not locked out are usually not minor. And in fact, if you'd like to look at something that will give you a very clear idea of what a serious injury costs, you can go to the OSHA website, osha.gov, and in the search function, look for safety pays. And there you'll find a formula that will allow you to plug in your direct cost of an injury and your profit margin, and it will tell you exactly what that injury will cost you in terms of producing a product and selling a product in order to recover that cost of the injury. And like I said, these injuries are typically not minor injuries, and you will be astounded at how much product you're going to have to produce and sell just to cover the cost of that one particular injury. The Lockout-Tagout standard establishes our responsibility as employers to protect our employees from hazardous energy sources that drive machines and equipment while they work to keep our processes and facilities running. The procedures that we put in place in our Lockout-Tagout program will go into effect when it is necessary for an employee to remove a guard or bypass a proximity switch or a safety device if they need to place a hand, an arm, or a part of their body into the danger zone, or into any area of the machinery that will be considered the point of operation. The point of operation is defined as the area on a machine where work is performed. This will also include the areas in which you find belt drives, gears, pulleys, or other power transmission devices. So before we get started talking about the elements of the standard, let's jump into a discussion about some of the terms and phrases that we're going to be using, just to make sure we've clarified some of the details. We're going to be spending a lot of time talking about the authorized employee. The authorized employee is an individual that we've instructed how to implement a lockout, and that person knows the procedural steps that we have developed to safely perform work on equipment. This instruction provided to the authorized employee would be, first, how to perform energy source isolation, second, how to implement lockout, and third, how to dissipate potential stored energy, and then how to verify energy operating condition. Another employee that we have is the affected employee. This is the employee whose typical job or main job function it is to operate equipment, like production equipment or packaging equipment. These are typically our machine operators. They operate the machine that an authorized employee has locked out and will be working on. Now, we can also refer to affected employees as the individuals whose job requires him or her to work in an area where service or maintenance will be performed. These could be line employees who are not necessarily operating the machinery, but they might be manipulating product, placing product into packaging, or loading cases and pallets, that sort of thing. It can also include QA or QC techs who might be checking critical control points or taking product samples. An affected employee can also become an authorized employee when that employee's duties include performing service and maintenance covered under this standard, and when they have been properly instructed on how to perform lockout. A lot of times you'll have production employees that will also service and maintain equipment, like clean up equipment either before a product changeover or after a product run. Those individuals, those affected employees, typically, when they get into that piece of equipment, they are now an authorized employee and have to be trained in order to do that work. The standard requires authorized workers to apply their locks to an energy isolation device before starting work to isolate the energy and to protect them from the equipment or machinery being started by someone who may not realize that there is someone in the machine and work is being done. According to OSHA, an energy isolation device is a mechanical device that physically prevents the transmission or release of energy. The OSHA definition goes on to explain that energy isolation devices include, but they're not limited to, a manually operated electrical circuit breaker, a disconnect switch or a three-phase disconnect, and a line valve or a blocking device. The definition also tells us that energy isolation devices are not push buttons, they're not selector switches, and other control circuit devices are not considered energy isolating devices. As an example, a regular push button on-off switch or toggle switch for a piece of equipment or machinery is not an energy isolation device. That's because it only isolates one phase and not all three phases of a power system. The machinery is still energized and under power when only the control circuit is used. The example on this slide is an emergency stop switch, which is typically a control circuit and not a disconnect. Sometimes you're going to see a guard or a shroud around the push button that will have slots or holes that will accept a lock or a tag. This is not an acceptable lockout or energy isolating device, despite the fact that equipment manufacturers will install these on our machinery. These are some examples of energy isolating devices that we are gonna have in our facilities, or that we may be using to isolate energy control sources. The disconnect in the upper left is a 3-phase disconnect that will isolate electrical energy from the equipment. The breaker panel in the upper right is also an electrical disconnect. The shutoff valves in the lower center may be used to isolate compressed air. We're often going to be device like the jack pictured here is also going to serve as energy to control the energy in the form of gravity, typically. The type of energy isolating device depends upon what drives the machinery and what stored energy we might have in that equipment. There's going to be many forms of energy that we're going to need to keep in mind and look for as we develop our lockout procedures. The typical form of energy is electrical. Most of our machinery is driven by electrical energy, and when we find opportunities for improvement in lockout procedures, it's typically because other forms of energy have not been included. Chemical energy is also a form of energy that we're going to have to consider. Hydraulic energy and high pressure steam, compressed air, and like I said, compressed air is commonly used in machinery in our facilities. And there's another type of energy that we often leave out of procedures, and that would be gravity. Gravity and the steps we need to control this form of energy is so often left out of procedures and not considered. But we must consider it and include the means to block or secure the equipment and explain how to do this in our procedures. A very common example of a piece of machinery with gravity as stored energy would be a dock leveler. We need to get under dock levelers or behind them to repair the mechanisms or clean the area below the dock or behind the dock leveler. And when doing so, we expose the employees, the authorized employee, to a seriously dangerous form of energy if we have not explained how to isolate that stored energy. These dock plates can sometimes weigh as much as 1,500 pounds. The vertical pipe that you see in the upper right picture would be an example of a blocking device used unexpectedly on the individual that we have inside there, either servicing, maintaining, or cleaning that area. The dock leveler in the lower left typically has a blocking device that's installed behind the dock plate. There's a bar that will come out and then a slot where you can put in a cotter pin to hold it in place. And that's going to prevent that dock leveler from coming down unexpectedly. Some of the models also have metal bars on either side of that dock leveler that are bolted into place. And you can unbolt them, shift them down and at an angle, and then bolt them back into place, and they'll keep that dock leveler from coming down and block that stored energy in the form of gravity. The lockout device is a device that utilizes a positive means such as a lock, keyed lock, or even a combination lock. And these locks will hold the energy isolating device in the safe position and prevent someone inadvertently or accidentally starting the machine or equipment while somebody's working. There are also many types of accessory equipment and that will help to secure the energy isolating device. These are cord and plug boxes that accept a lock, valve covers that will take a lock or several locks, wheel valve covers, wire rope cables that can be used to lock out several disconnects at a time. There's just all kinds of accessory equipment available to us. Now, we've already mentioned service and maintenance. And so just exactly what does that mean specifically? Servicing and/or maintenance can include installing, setting up, adjusting, inspecting, modifying, and maintaining or servicing machines or equipment. These activities can include lubrication, cleaning equipment, adjustments or part changes when the employee may be exposed to the startup of the machinery or the release of stored energy. OSHA tells us that under no circumstances, they're very clear about this, under no circumstances is any part of an employee's body ever permitted to be exposed within a hazardous area, such as the point of operation during service and maintenance activities while the machine is running or energized. So in the food industry, We obviously spend a great deal of time cleaning equipment. It's a must. So the employees whose job it is to clean equipment and machinery will be performing service and maintenance, and they must be trained as authorized employees. Tagout. Tagout's a term that we use often. The expectation in the standard is that you should consider tagout only when and only if you cannot physically lock out the equipment and isolate the energy. In fact, the standard and the compliance directive tells us that simply using a tagout is not fully acceptable. Additional information in the standard and in the directive for OSHA compliance officers will speak to Tags Plus. We will get into Tags Plus definition and the approach a little bit later, but it's just important that we understand that really what we have are two separate programs. We've got to look at lockout as one program and tagout as a separate program if we can't actually lock out the equipment. We'll get into that a little bit later. So I think we've covered most of the definitions that we need for now. So let's get into the written program requirements. The standard requires us to establish the lockout procedures, employee training, and periodic inspection. These elements are intended to make sure that when it is possible, unexpected startup or the release of stored energy could happen and cause injury. That machine shall be isolated from the energy source or energy sources and made inoperative, and authorized employees will have the knowledge and skills to identify hazardous energy and the means and the understanding how to isolate the equipment from all forms of energy. When you break the standard down into those basic elements, it first appears to be rather simple, rather straightforward and basic. But there are some expected outcomes that OSHA has of us that add to the complexity of the program. And like I said, in my view, this regulation, even in its basic approach, is critically important in our efforts to keep employees safe and avoid serious, life-altering injuries or fatalities. To add to the complexity of the standard when printed is only about 2 pages long. However, there is a 136-page instruction manual on the enforcement policy and inspection procedures that OSHA provides to compliance officers to help them understand how they are going to apply the regulation when they pay you a visit. And to add more focus on the regulation, there's a national emphasis program on amputations, which focuses a great deal on this regulation and which is aggressively used in many manufacturing facilities across the country. Because generally, when an amputation takes place, it's going to be because our lockout-tagout program failed. There's also an American national standard on the control of hazardous energy and alternative methods that should be considered when implementing a comprehensive program, and especially the alternate methods of compliance. This standard is the ANSI/ASSE Z244.1-2016, the control of hazardous energy, lockout, tagout, and alternative methods. And this standard, interestingly enough, when it first came out, was what OSHA used as the model for their current regulation. So let's focus for a while on the lockout procedures themselves. If I hadn't said it yet, I'll say it now. If we don't have equipment-specific lockout procedures for our equipment, and if the procedures that we have are not accurate, then we really don't have a lockout program. At a minimum, these procedures must include a statement of the intended use of the procedures, specific procedural steps for isolating machines or equipment to control hazardous energy, specific procedural steps for the placement of lockout devices, and specific requirements for testing a machine to verify the effectiveness of lockout. You'll notice that the last item on the list in the slide indicates the need to enforce the program and the procedural steps for isolation. So my recommendation is to make sure the procedures are well understood and the expectations are well understood and are followed specifically, and we're not taking shortcuts. So oftentimes, as I begin to audit or assist a company in writing lockout procedures and help with the development of their program, it's been my experience that one thing will come up occasionally that tends to be misused and misunderstood. This standard includes an exception. A lockout procedure does not need to be written. So if the machine has no potential for stored energy, if the machine has a single energy source, if there is a single energy source that will completely de-energize the machine, and the lockout device is under the exclusive control of the authorized employee, and the task does not create hazards for other employees, and if there's been no accidents when this equipment's been locked out, then we do not need to write a lockout procedure. The problem is, occasionally, I find that some will come across this section and read it to mean that the authorized employee does not need to lock out the machinery. They look at it as kind of a blending of the cord and plug exemption, which says you don't have to lock out a cord and plug assembly if you have direct control over that cord and plug. It does not mean that the equipment doesn't have to be locked out. It just means you don't have to write a specific procedure. But I recommend these exceptions to writing the lockout procedures be considered very thoughtfully. Confusion will set in with authorized employees when some equipment has to have a procedure written and some don't. It's also harder to enforce failure to lock out or taking shortcuts when there are no specific procedures to follow. All right, so let's get into the process of writing a lockout procedure. I know this slide's very busy, and I don't expect you to be able to read everything on it. I just kind of wanted to give you the 30,000-foot view level of a lockout procedures. I wanted to include this as an example in the discussion to give you an idea. This is the first page of a 2-page lockout procedure. This is the type of procedure that I use for clients, and it makes the step-by-step process very clear. It helps employees identify and locate the energy isolating devices, the method of isolating energy sources, the equipment needed to lock out the energy source. It identifies the controls and the method of testing and verifying that we have in fact succeeded in isolating the energy and making it safe to work on the equipment. It also, these types of procedures also prove very helpful to employees that don't use English as their primary language. So let's consider the process of writing equipment-specific lockout procedures. Here's what I recommend. First, you'll need to compile an inventory or a list of all the equipment that you service, maintain, adjust, clean, replace, repair, anything, basically anything that's got an on-off switch. I typically begin at the start of a process and work my way through to packaging until I've completed all process lines, and then I begin working on the additional machinery that we're going to have in our facility and make sure that we've got procedures written for that as well. The next step will require some scheduling coordination. I like to find an individual, it's typically the maintenance person, who knows the equipment. I'm going to have that person help me to be sure that I identify all forms of energy and how that energy is isolated. I have them walk with me through the procedure. I ask them questions. I ask if there's any other type of energy like air, hydraulics, any situations where gravity may be present, capacitors, electrical capacitors, springs, and so on. I like to have them help me trace electrical conduit. I like to make sure that I get the right disconnect. A lot of times equipment is modified, things are changed, things are moved, and if you don't have somebody there that's been around when some of those changes have been made, you may get the wrong disconnect just simply by following electrical conduit. So it's always helpful to have that person with you. Now, considering the steps, make sure that they are accurate as you plug them into your template. Go through each step and make sure that you've got them right. Write them down and take a picture of the controls, the energy isolation devices, and where the lockout and tagout will be applied. This will make the easy reference when you write the procedure. Or I will put the procedure together as I go through the equipment. It's easier to do it while you have the person with you and while you're in front of the machine. That way you can discuss the process and make sure you don't miss anything. This is the, let me go back here, I'm sorry. This is going to be the top section of the procedure. It's going to identify the machine and the department in which we find the machinery. And through your training, the authorized employee will tell the affected employee or affected employees, in this case, the line 1 robotic tray packer operator, and the employees in the area that work is going to be done on the tray packer. We've also included an enforcement statement. This section also gives the authorized employee an idea of how involved the lockout procedure will be by letting them know that there are 3 energy isolating points on this machine. This is the authorized employee identify the equipment, which is in the upper left-hand corner, and the electrical disconnect, or the E1 tab that you find in the upper right. The 2 photos in the lower left are used to identify the location of the shutoff valves for the compressed air lines that power or drive the tray packer. These are identified as the P1 and P2 tabs. The middle picture also identifies the control for the compressed air and the gauge that will tell authorized employees if the pressure has been released to a 0 energy state. The instruction that we're going to get to in a second will explain how to release the stored energy or if there is an automatic dump valve when the air is shut off. The instructions that we will review a little later will explain which step to take and to be sure to observe that the gauge is at 0 energy. The picture in the lower right shows us where the controls are and where we test the machinery to make sure it's been isolated. The controls for the equipment and the compressed air are identified by the C1 and C2 tabs. When writing the procedure, I would suggest thinking down the list of steps that OSHA wants to see in the procedure. First, you'll have to shut down the machine by the normal means, and this will identify the controls that you will be using to identify the steps. Start to identify the types of energy and the magnitude of energy, and also identify where the energy isolating device or devices will be located. All forms of energy need to be identified, and the means to shut the power off and isolate it from the machinery are identified here in these pictures. The left-hand picture shows the location of the compressed air shutoff valve, and the upper right picture shows an additional shutoff valve. These are identified by the tabs P1 and P2. In the picture in the upper right, we also have the controls for the compressed air. The regulator just next to the shutoff valve has a pressure gauge that we will look for to show a 0 energy state when the pressure is released. The control is identified by tab C2. And you already have the picture for the equipment controls, and this is going to help the authorized employees see where they go to test the machine. Another busy slide, and I apologize, but this is the second page of the procedure that we're reviewing. And all the pictures that we just reviewed will correspond with the specific instructions on what energy we're dealing with, the magnitude of that energy, and the step-by-step process for isolating and testing the machinery. Taking the top half of that second page and giving it a closer look, we see that the ID tags, E1 for the electrical energy, and P1 and P2 for pneumatic energy. The other procedures that we're going to put together will have equipment ID tags for other forms of energy, such as natural gas, and you can mark that as NG1. Hydraulics could be H1, gravity could be GV1, steam ST1, and so on. You can use whatever abbreviation or color code that you want for the other forms of energy. It's important to stay consistent with the color codes and the abbreviation from procedure to procedure, so they're not confusing. The second column that we have corresponds with the ID tag and explains the energy form and the magnitude of energy. The magnitude of energy is required by OSHA, and it has to be identified on our procedures as another form of communicating the seriousness of the energy that we're working with. The third column also explains what type of lock, case where we've got pneumatic energy or pneumatic air, a valve cover, lock, and tag. The fourth column adds to the information by indicating the location of the energy isolating device and is further shown in the pictures that correspond with this section. The method of shutting down and isolating the energy is included. And last but not least, an explanation of how to test and verify the equipment has been isolated from all forms of energy. There's also, in this example, a reminder to return the operating controls to the off position. Another quick look at the busy slide. I know this puts both pages together for a quick look. On the left, you've got the pictures of the equipment, the electrical energy isolating device, the pneumatic shutoff valves, the location of the regulator valve that you'll use to release the stored compressed air, and the controls you will use to test and verify that Lockout has isolated the energy sources. On the right-hand side, you have the step-by-step instructions that will coincide with the pictures on the right, or on the left, making it very clear how to isolate this equipment from the energy source and stored energy. One thing we haven't talked about so far is the requirement to include instructions on how to bring equipment back to the powered state safely. And these steps are included on the lower half of the second page of our sample procedure. The step-by-step process to bring equipment back to power will include checking the machine or equipment to ensure that all our tools and all the items that we've been using have been removed and the machine has been put back together again. We're going to check the work area to make sure all employees and other authorized employees are out of the area. We're going to remove the lockout devices and re-energize that machine. We're also probably going to need to identify when the removal of blocking devices may require startup of the machine before they can be removed. And then notify affected employees the job's done, machine's ready to go back to use. And if I may make a suggestion, I would include the startup or re-energization steps in your training and in your annual reviews and in your lockout procedures. So in a nutshell, these are the steps that we will use to outline and template for our lockout procedures, and the steps the authorized employee is going to take to isolate energy from equipment. The authorized employees must notify the affected employee that the machinery will be shut down and lockout will be done. This is a communication step to make sure the employee or the people who operate the equipment are not involved, who are not involved in the service or maintenance, will know that they are not to try and operate the machine. It's an important first step, and communication is an important safety step. We're going to shut the equipment down by the normal control method, shut it down at the off switch, identify the energy forms and the magnitude of energy, where and how to deactivate the energy isolating devices, the electrical disconnect or pneumatic shutoff valve. We're going to apply the lock, the valve cover, or lock, and insert a blocking device, etc. If there's stored energy, such as pneumatic energy, where and how do we dissipate, release, or block the stored energy? And then lastly, number 7, but in my opinion, just as important as all the other steps, we're going to talk about the procedure where we test to make sure the equipment will not start up and how you will verify the equipment has been isolated from all forms of energy. In so many unfortunate situations where lockout has not been performed properly, this is the one step that people tend to skip because it's easy to forget, or there doesn't really seem to be much of a need for it when you've gone through all the steps necessary to isolate the machine from its energy sources. but it is so very important for many reasons. And these are some of the reasons. The disconnects in this slide depict some of the issues that I've run across during an inspection. These are examples of observations made on the production floor that honestly frighten me. These are cases where equipment will still be energized while the employee is working if they don't take the time to test the machinery to make sure the disconnects have functioned as they're supposed to. In the upper left, I walked up to that disconnect or that control panel, and the disconnect was in the off position, but all the control lights, all the indicator lights were on. And when I got an electrician to open the panel for me to try to figure out what was going on, we noticed that you can see that rod that sticks out from the left, and there's a circle around the end. And on that end, there's supposed to be a pin that fits into a receptor at where the fuses are open when that disconnect is turned to the off position. Well, that pin was gone, and it was broken, and it wasn't working properly. And then in the lower left, there's a three-phase disconnect. There's a knife handle that you pull down to open up those circuits, but you can see the left one is broken and it's still intact, and the equipment is still energized. And then in the upper right, there's a red and yellow employee got into a piece of equipment without shutting it down, without going through the lockout procedures, because the disconnect was broken and he couldn't shut it off. And then in the lower right, we've got a broken pressure gauge valve that won't tell us whether or not we have in fact dissipated the stored pressure in that particular piece of equipment. So these are common examples of things that I find, and common examples of reasons why we need to make sure that we test the equipment to ensure that we have in fact isolated all forms of energy to that piece of equipment. When it's necessary to have more than one person involved in service or maintenance on the same machine, you could have people using gang clasps that are often used. These gang clasps they open up like a pair of scissors, and then when they close, there's 6 holes that line up for individuals to insert their lockout locks. This is a form of group lockout that will provide protection for each authorized employee. A lockbox like the one pictured here is also a method used when several employees are involved in service and or maintenance on the same machine. An authorized employee will have responsibility for the process, and that individual will apply lockouts on every energy isolating device. This is usually done when there are several types of energy and energy isolating devices and several people working on that piece of machinery. The key or keys to all the lockouts applied to the machine will be placed in that box, and then each authorized employee will then place their lockout on the box. This way, each person is protected because they will have their lock on the box that contains the keys for all the lockouts. So when everyone is done performing their job, they go to the lock box and remove their lock. The last person to finish work is still protected because their lockout is on that box, and the keys to the lockouts on the energy isolating devices are within that box. It would then be the last person's responsibility to proceed through the steps and safely return the equipment back to operational status. Now, I quickly talked about the cord and plug exception earlier. This is the only time that OSHA does not require you to lock out a piece of equipment, but it comes with a caveat. The cord and plug has to be the only form of energy to that piece of equipment. And if you, as the authorized employee, can unplug that piece of equipment and have direct and complete control over that plug end, then you don't have to lock it out. You can stand on that cord and plug, you can put it in your pocket, you can drape it over your shoulders, you can keep it right in front of you. As long as you've got control over it, you don't have to lock it out. But let me give you an example. A conveyor system driven by an electrical motor. You unplug the electrical motor, completely isolated from its energy source, but you as the authorized employee step away from that plug, that drive motor, work on the far end, the back side of that piece of equipment. You are no longer in control of that cord and plug. At that point in time, when you lose control of that cord and plug, then you have to lock it out. But as long as you've got control, this is the only exception to locking out a piece of equipment. Another element of the standard explains what we must do when an authorized employee leaves his or her lockout on a piece of equipment. This may happen when an employee forgets to take a lockout device off the energy isolating device, or they haven't finished work on the machinery and they are not aware the equipment will be needed. There are many reasons, but how do we deal with this situation? First of all, we need to anticipate that this will happen, include the procedures in our written program and in our training. We will need to develop procedures that explain how this process will take place and include a method of documenting the steps taken to ensure that the safety of all involved. We will need to make every attempt to make sure the employee is not in the facility. We don't want to remove the lockout device only to find the employee is still in the building and have them return to the equipment thinking it's locked out and have them get into the machine after it's been returned to power. We will try to locate that individual. We'll call them at home, call them on their cell phone, call them at their favorite restaurant, just whatever we need to do to get a hold of them. And if we make contact with them, we can ask if they forgot to leave the lockout on the equipment or if they were still working on the machinery. What's the status of the service and maintenance, in other words? If they were finished and just forgot to take off their lockout, they can come back, if that makes sense to do, and remove their lockout device, or the individual designated to remove the lock can go ahead and take the lock off. This is going to be typically somebody, this designated individual is going to be somebody with responsibility for the employees. Now, they shouldn't remove the lock with a spare key. There should not be any spare keys. The lock probably should be removed by bolt cutters. This will help kind of reinforce the importance of the lock and how that lock is that individual's, that authorized employee's assurance that they're safe. If we've not been able to make contact with them before their next work shift, we're going to have to make sure that before they get back into the work area that we intercept them probably at the we had to remove their lockout. This way, we can be assured that they won't assume that it's safe to go back into that piece of equipment and begin service and maintenance like they just left off. We don't want them to do that when in fact the lockout's been removed and the equipment's powered up. Now, the minor servicing exemption or exception was added to OSHA to allow a little room to ensure production and safety can come to terms and find a way to operate cost effectively and safely at the same time. What makes it difficult for us to comfortably apply this minor service exception is the difficulty that we have in understanding exactly where or when or even how to apply this exception. According to OSHA's directive and enforcement policy for addressing the standard, the general rule is that servicing and or maintenance must be performed under lockout-tagout requirements. However, the lockout-tagout standard is not intended to cover minor servicing activities, which are necessary to carry out production processes, provided that all the criteria detailed in the exception are met. But this exception is very difficult to apply, and it's very vague. But if we choose to apply it, we've also got to include that the effective alternate forms of protection for our employees. So we're tasked with determining when the minor servicing exemption can be applied. And if our intentions meet the exception criteria, like I said, the criteria is vague. Even OSHA admits that this is a vague explanation. For us to determine if we can use the minor servicing exception, we must first determine if the activity must be conducted during normal production operations, but not during normal downtime, not during preventative maintenance, and not during part replacement or repair. In these cases, lockout will apply. The second activity must be routine. The activity must be a regular course of procedure and be in accordance with established practices. But what exactly is routine? OSHA has not defined that. And repetitive. The activity must be regularly repeated as part of production process. But what is repetitive? Is there a practical difference between routine and repetitive? And then lastly, integral. The activity must be essential to the production process. What does integral to the use of production equipment mean? Is lubrication integral, or unjamming, is that integral? They just haven't defined that. And third, if we can determine that all these apply, the employer must use alternative measures to provide effective protection from hazardous energy. If you choose to move forward with the minor servicing exemption, you must include written alternative measures. Alternative measures can be powerful and productive tools, but they still require diligence and teamwork to outline, develop, and implement. If you decide that you've identified an activity or task that meets the minor service exception and meets the criteria for routine, repetitive, integral to the production process, I recommend that you treat the process just like you would the development of an equipment-specific lockout procedure. This would mean utilizing a hazard assessment, identifying the hazards with each step, identify the safety measures required in order to assure employee safety, test the alternative steps, audit the assessment and alternative measures, and train to them, and include them in your member. Any alternative measure developed must provide the same level and protection as Lockout-Tagout. So using the minor service exception is a difficult and confusing decision to make. Wade through the confusion and vagueness and try to come to terms with using an exception and keeping your employees safe. But just be aware, OSHA will most likely stay with the need to lock out the machinery if it means that this is the most safe and secure method of getting into machinery. And so now that that's totally confused you, let's move on to something a bit less confusing. Lockout is a more effective means of ensuring employee safety, but it is the preferred method because lockout safety programs are less susceptible to human error and tagout devices have limitations. If all our equipment can be locked out, and this is important, if all of our equipment can be locked out, then this will not even be a concern for you. You won't even be able to apply a tag. So if the energy isolating devices cannot be locked out, the standard requires the employer demonstrate that a tagout system fully provide protection to the employee at the same level that a lockout would provide. In order for the employer to demonstrate that a tagout program is as protective as lockout, the employer will need to show additional elements which bridge the gap between lockout and tagout. A key element in demonstrating that the tagout program bridges the gap is the standards provision that the tagout program provide at least one additional safety measure. In other words, at least one added step that we have to put in place to make sure that tagout will prevent unexpected re-energization of the equipment. Such additional safety measures as described by OSHA might include the closure of a second inline valve, a double block and bleed, removal of a valve handle, or locking, blocking, or barricading equipment. OSHA expects us to include a tagout procedure with the lockout procedures and develop the tagout procedures in the same way we develop lockout procedures. I think it's important to review that even though it may not be a common approach, to me, if we have equipment that cannot be locked out, let's modify the equipment so that it can implement an effective lockout. In most cases, we can add a disconnect and just be done with it. Periodic inspections are another requirement and often misunderstood expectation. The periodic inspections of all procedures and authorized employees we need to perform periodic inspections because of the significant risks with inadequate energy control procedures and the failure to properly implement effective energy control procedures. OSHA requires that periodic inspections be performed at least annually to verify that procedures are adequate and being used properly. According to the compliance directive, each energy control procedure required by the lockout standard must be separately inspected to ensure that the energy control procedure is accurate and being properly implemented by the authorized employees. OSHA requires that the periodic inspection include a review between the inspector and each authorized employee and the employee's responsibilities indicated in the energy control procedures being inspected. The inspections can be done through random audits, safety tours, or planned visual observation. The inspector must observe the authorized employee perform the energy control procedure and talk with employees as they implement the procedure to determine that all the requirements of the procedure are understood and being followed by employees. There is some reprieve by OSHA, and it states that energy control procedures used less frequently than once a year need to be inspected only when used. That gives us a little leeway. The other little leeway that we've got is that if we have machines that are grouped together on one lockout procedure, such as packaging machines that are all the same, OSHA states that the inspector does not have to observe every authorized employee implementing the energy control procedure. Rather, the inspector may observe and talk with a number of employees in order to obtain a reasonable reflection of the work practice being performed. But that's just on grouped equipment. The inspections have to be documented, and the documentation must include the machine or equipment in which the energy control procedure was used, the date of the inspection, the name of the employees included in the inspection, and the names of the person who performed the inspection. The idea of documentation is to provide us with a means to determine if the employee is in compliance, but most importantly, the inspection provides us the assurance the employees understand and follow the procedures properly. One requirement for training employees centers on the fact that if deficiencies are identified with employees as we perform the inspection, then we need to retrain employees in how to properly lock out equipment. In order for training to be effective, that training program must address at a minimum the reason for the energy control program, the elements of the energy control procedures, and requirements of the lockout standard. When inspections show employees may not follow the program, retraining must make sure employees understand the procedures and, if relevant, address any new or updated energy control procedures, and retraining must identify the problems or lack of understanding and eliminate those problems. I would offer one bit of caution. Be careful when using canned or online training programs. They're too generic, and OSHA is not a fan of generic training. Although the standard does not prescribe annual refresher training or set frequency of training, it does require training and retraining under specific circumstances and specifies those issues that the training must cover. For example, the employer must provide initial training before the servicing and maintenance activities begin and must provide retraining as necessary. Now, most everyone I work with will train at least on an annual basis, and I feel that annual training in addition to the retraining requirements is a must. It is the best way to keep the elements and requirements of this program at top of mind of our employees and management. Retraining is required if the periodic inspection reveals problems or non-compliance with using procedures and policies correctly. Additionally, retraining must be provided for all authorized and affected employees whenever there's a change in job assignments, energy control procedures, or machinery, equipment, and processes that present new hazards. One of the most difficult things for us to keep track of when it comes to any type of safety training is the movement of employees, whether from job to job or just simple employee turnover. It's also difficult for us to remember, with all the commotion that goes on in the manufacturing environment, that we must revisit the information and training aspect of this requirement when problems are found in the program and when inspections show a lack of understanding. But as I've said before, it is likely the most important program that we're going to implement to ensure the safety of our employees. It is one program that we must always be on top of, and always observe for signs of misunderstanding, shortcuts, and risk-taking. With a focus on training, review, discussion, observation, procedure update, and corrective action when necessary, we may easily save an employee from serious injury. We may also save a life by doing these things. And to me, that's why we are in the business of safety. Any questions?
Great, John. Thank you so much. Can you hear me?
Yes, I can.
Great, perfect. Thank you for such a great presentation. I'll get started with a few questions that have come in. The first one is, can another worker be used as an active lockout or to watch the switch to make sure no one starts the machine?
Well, no, the answer to that is no. And I've seen that done before. And I mentioned earlier that communication is so important in maintaining the safety of the authorized employee. But here you're limited to an individual listening to somebody else's instruction, and they might easily be distracted. They might easily mishear what the person says and start the machinery when that authorized employee is still in that piece of equipment. OSHA will not accept this as an active lockout or a lockout observer or lockout watchout, whatever you want to call it. It's just not going to meet the intent of the standard.
Okay, thank you. Next question, do we have to do lockout inspections all at once, or can they be done throughout the year?
No, they can be done throughout the year. You can set up specific inspections, watch an individual perform lockout, an actual lockout. You can take a look at the preventative maintenance schedules. You can kind of keep your eyes and ears open for whenever a piece of equipment goes down. There's all kinds of ways that you can set up these inspections. They don't have to be done all at one time. You can spread them out over the course of the year.
Okay, thank you. Our next question is, we use temporary employees to help clean equipment. Are we responsible for their lockout training, or is the temp agency?
Yeah, well, short answer again, yes. If you're supervising those temporary employees, and if you have them involved in service or maintenance, cleaning a piece of equipment, or even getting into equipment to unjam product or packaging, they will have to be trained in the lockout program. Whenever you have a temporary employee and you supervise their daily activities and you direct their daily activities, you are completely responsible for them. Now, even temporary employees who you don't direct, who you don't supervise, if they're on your floor, you need to make sure that they are trained as affected employees or other employees that will be around lockout and tagout and may be associated with what's going on. They have to know that a lockout on a piece of equipment is not something that they can remove or try to bypass.
Okay, thank you. If there are any other questions in the audience, please go ahead and type them in real quickly, and we'll get them in before our 2 o'clock ending. But I do want to thank you, John, for your presentation today on Lockout-Tagout. I think it's particularly pertinent in today's world with employee shortages, moving around of responsibilities to ensure that everyone is properly trained on all safety protocols. I also want to mention, if you're in the audience and you are in the dietary supplement industry, our next complimentary webinar is on April 16th, and that is on traceability of dietary supplements and serious adverse events reporting. I think I might have one question over here. Let me just look. Oh, nope. Thank you for the, oh, here we go. Here's one more. Would you need chain guards or a way to lock out, tag out a piece of equipment even though it is non-motorized?
An example might be something that has gravity in as a source of energy. And yes, if there's that potential for that to be released unexpectedly and come down or move in such a way where an employee could be caught in that machinery or that piece of equipment, then yes, it would have to be blocked up, chained up, somehow restrained and held in place to prevent it from moving unexpectedly. That's a good question. That's something I hadn't really thought of. But there are situations where there is a lockout that needs to be done on machinery that's not powered up typically.
Okay, perfect. Well, thank you all again. You've got John's email if you have additional questions, as well as Alan Saylor, our Senior Director of Food Consulting Services. EAS would be glad to help you in any of your OSHA-related regulatory compliance needs. And we thank you for joining us today, and thank you for your interest in EAS. Have a good day.